What's up, YouTube? I'm Robert, and this is the Biker Bar. I can't say B1 after that. That doesn't make any fucking sense. So, already see a few people here showed up today. Brian T started out with a $5 super chat for the beer fund. That sounds like a plan to me. So tonight's episode is going to be hosted with me and Scott from Knight Composites. Scott, you want to say hello?
Hey guys, how you doing?
So if you guys aren't familiar with Knight Composites, they're actually a carbon wheel company. And actually, I'll just let Scott go ahead and you want to give a little intro of the company and we can go from there?
Sure, guys. So, hey, we're really happy to be here. I'm a little sad that my beer is out of my reach right now, but that's okay. I want to tell you a little bit about Knight Composites. So Knight Composites is a carbon wheel company that is based in Bend, Oregon. We're all a bunch of industry veterans. Our founders, Jim File was one of our founders. He started a little company called Reynolds. Beverly Lucas is another founder. She was at Felt, and both her and Jim were at Edge Composites, which of course became Envy. And then Kevin Kwan, who was a lead engineer at Cervelo. Everybody kind of came together and decided that you could form maybe have a different spin on how to make a good carbon mountain bike wheel. And 4 years later, we're here with 15 products and a World Cup win, and we've actually won a stage at the Vuelta a España as well. So we've come a long ways in a short period of time, and we're just going to continue to grow.
Man, you guys really have a powerhouse of people there. So basically, almost sounds like you cherry picked all the other carbon industries out there, right?
Yeah, I think that the industries kind of cherry picked themselves, and then the folks that just always wanted to keep innovation at the forefront of really continuing to progress the industry, just like we see in suspension, just like we see in frame design, frame geometry. I mean, just because a wheel is a bicycle hoop doesn't mean that innovation stops when you come up with a new material to use. So that's kind of where Knight was born out of, because our company's had a history with working with composites before, and we kind of look at ourselves as like a third generation wheel company.
Right on. So somebody in the chat's mentioning that you got the SF Giants. How you originally from the Bay Area, or?
Nope, I just love the Giants.
Just love the Giants. All right. Well, I won't pick any bones with you there.
I know you got a bunch of Dodgers fans that are probably on here, so I'll just go ahead. Nice and prominent for you guys.
Right on. So let's talk just, the Biker Bar is a show that's on every week, 5 p.m. PST, and we like to have different people on the show, and sometimes it's bikes and sometimes it's not. I just kind of like to have a casual conversation and kind of go on from there. So maybe so people get a little to know you a little bit. I think you had an industry that you were with another bike company or bike type of company.
Yeah. So I don't know the age group that is kind of most of your viewership, but way back in the day, Cane Creek used to make bicycle wheels. We made the Chronos and the Wham, and we had a hub design called the Chrono hub design, which it was radially laced non-drive side, 2-cross drive side, offsetting flanges, and we had nipples at the hub. So I was a part of Cane Creek back when they were doing wheels. They stopped doing wheels right around the 2006 time period, and so that was kind of my previous industry experience. And then I got out of it. Actually started working on the medical side of things, and then about 4 years ago had an opportunity to get back into the bike industry when Jim and Beverly and Kevin started Knight Composites. And honestly, I mean, I've been building wheels for a long time, 16, 17, 18 years of wheel building experience. And I built thousands and thousands and thousands of wheels. And initially when I came back to them, it was just to kind of help them out with fulfilling an order. And out of that, in a very short period of time, I was managing product and helping the company to kind of move forward. And the biggest thing to take away from that is much like my time at Cane Creek, I was sold on the product. The product speaks for itself. It stands on its own 2 feet. And it was exciting to be able to work with. And just coming from the perspective of working with composites back in the early 2000s, when you get 20 rims out of a box and you would immediately lose the first 4 because they wouldn't pass QC, so you'd have 16 rims left to build, especially on the roadside. And then the build tolerances were it was hard to build a really good strong wheel back during that time period. And at the same time, like over the last 15 years, you look at how carbon fiber and composites have become essentially the industry standard. I mean, we see them raced at the World Cup level. Santa Cruz Syndicate was the first one that actually started racing them on downhill bikes pretty regularly, and it really gave the material some credibility. And it's incredible that it took that long to kind of happen in the bike industry, because we've seen composites used in aviation and in Formula One racing. So the highest level of performance, military aircraft, they've been using it for 30 or 40 years. And so the technology has kind of started to trickle down now, where we're seeing a lot of that in the bike industry. And at the same time, like, we're seeing developments in things like suspension. I mean, the metric suspension stuff that's coming down the pike. I mean, the quality of the forks that are coming out right now, and the quality of the shocks that are coming out. I mean, it's a really, really exciting time to be in the bike industry. And if you're not innovative and you're just kind of going through the motions, man, you guys, it doesn't matter what the name on the down tube said or what the name on the side of the wheel says, you will get left behind. So it's exciting to be part of that innovative side of the industry, and helping to kind of set trends that hopefully other companies will either try to copy and mimic and build their businesses on, or at the same time be inspired by something that another company is doing to kind of help us move our business forward.
So what is the process to build a carbon wheel? I think, is it, you don't just go down, like pour the car in the pot and the bond in the pot and screw it together.
It's not like making muffins in a tin, that's for sure. But the process is actually very similar. So there's a lot of different ways to do it. The way that we do it at Knight Composites is we actually use a process called expanded polystyrene. So just as an example for your viewers, a lot of carbon fiber you'll start off with kind of what's like a latex or just a vinyl bag, and you'll blow it up, you'll inflate it, and that'll be your mold. And it's like paper mache.
So latex bag, is that like code for a condom, or?
It could be. I mean, it depends on what state your company is based out of.
Okay.
I haven't heard of Trojan wheels yet, but I mean, who knows? Maybe one of your viewers will start that company after this conversation. But it's a good process. A lot of good companies use it, but it can be better. So one of the things that ends up leading to maybe a wheel failing, or even a bicycle frame that uses the same process failing, is you're limited by the amount of air you can put into that mold. So you have a predictable level of consolidation of your materials inside of a steel tool. And with our process, we lay our carbon fiber up around a preformed spoke bed. So it's the same consistent thickness in the spoke bed. And then by laying the carbon fiber up around what basically looks like, our EPS is molded into something that's very similar to a surfboard core. So because of that, we're able to get consolidation of materials with 4 stages of heat and PSI. We're able to go to much higher PSI than a latex or a bladder bag is going to be able to do. We're able to cure it during that process using high TG, low TG resins. And in the end, you don't end up, with a rim that has voids in the rim. Any void is going to be a weak spot that eventually impact or braking pressure or anything is going to find and expose. So
just so I'm clear, and they are as well, my understanding is that when you're doing carbon, you're kind of like laying down this little strips of like plastic paper in like a paper mache kind of.
You're laying down sections of it, and it could be pre-preg, it could be based off the different sizes, but it's multiple layers of overlapping, and it wraps around this mold. And then you add epoxy, you add resin, you add heat, you add pressure inside of a tool, and what comes out is essentially a frame that should, or a wheel that needs, or a handlebar that needs very little finish afterwards. Maybe a little bit of sanding, a little bit of drilling for the holes, or if you have DI2, or if you need a dropper post on your bike, they'll do that stuff in post production. And then you essentially you check it to make sure that it's within your tolerances, and then you paint it, or you gloss it, and you bring it to production. So with us, our process requires very little post-production rework, which allows our wheels to be very consistent when they come out of the tool. So if we do like our 27.5 Enduro wheel, for example, that's a wheel that's 28 holes. It's impact rated for 120 joules of impact. It's generally used on full suspension mountain bikes, guys that like to ride enduro. We benchmark that rim at 445 grams. If we make 100 of those rims coming out of 3 different tools that we have, most of our tolerances are within 15 grams on each rim. And that's because of our process. We're able to get that consistency without having to have the variances or having to pull a rim out of the tool, having some holes that we need to patch. So we've got to add epoxy to it and sand it down and re-cure it, which is going to add as much as 50 to 60 grams to a rim. So you'll see some rims that are out there that, you know, the variance is, it'll say it's a 500 gram rim, but you might get one that's 560. You might get one that's 440. So the variance is, it's not just about adding weight. In some cases, it can be less weight if you don't have lots of continuity and consistency within your process. And we'll see that, like Santa Cruz is a great example. Santa Cruz frames, they're very, very consistent when they come out of the tool. You can go to their factory, go to their warehouse. You can pick up 100 frames within a particular model, and you're going to see a lot of consistency in the way that those guys do business. So, and they're not the only one. There's other companies in the industry that have also adopted real consistent processes, both with their mountain and their road bike stuff.
So how do you guys? First of all, I saw somebody ask also if you do fat bike wheels. I know you do road wheels as well, right?
We do road wheels. Good question on the fat bike wheels. You guys should come to Interbike to find out if we do fat bike wheels. If hopefully that will give you an answer to your question.
Well, I'll see you in Interbike then. So I will be there. Moving on to that though, but back to the consistency that you were talking about. How do you go about maintaining that consistency? Is it like you guys have to, I'm assuming you do your production in China or something like that?
Yeah. So, I mean, we do our production in Asia. So the best, in my opinion, within our industry, the most experienced workforce that's available is available in Asia. And keep this in mind that, you know, I hear some people sometimes they're coming down on, oh, you know, it's made in Taiwan, it's garbage, made in China, it's garbage. The amount of available workforce that has experience working with composites and carbon fiber, because of the nature of our industry, the fact that we have been doing a lot of our manufacturing overseas for a long time now, we have the most experienced workers available to us by using either Taiwan or China for our manufacturing process. So we work with a factory that is based in Taiwan. They do, we know the workforce, we know the engineering staff, we know everybody that is involved in our process. They understand exactly what our expectations are. And because we have a mutual partnership with them where they know, like, listen, you can't make decisions without looking at our benchmarks as kind of, this is acceptable, this is unacceptable. It allows us to trust everything that's coming out of there. Plus, I mean, I've got a ton of frequent flyer miles because I've gone and I've visited. And then we also have a trusted trade agent that we work with who's also Taiwan based, who does random batch testing, pops in, is essentially holding our manufacturers accountable to the benchmarks that we've set. So one thing that we've done that that was a little bit difficult to put in place because the culture was not in place when we started working with these guys, is we want every 100 rims that we manufacture, we pull it out of production, we build it up, and we retest it. We retest it to all of our developmental standards of impact, lateral stiffness, radial stiffness, durability. We put it on the drum machine with a big bump stop on it and just keep pounding on it, because we want to make sure that, you know, it's one thing to develop a wheel and test it and have it approved. It's another thing to continue to maintain that consistency through the manufacturing process.
Yeah, that's definitely quite the process. I mean, you're definitely in, I mean, every 100, that's QC and like a motherfucker.
Yeah, that basically means that every one of our rims goes through the QC process about once a month. So right. I mean, that's keeping our sourcing of our materials, making sure that, you know, if I say that the rim's supposed to be made with Toray T700, Toray T700 is what's going into that rim. And you know, that's something that, you know, with our engineering team and with our product team and with our QC and then also with our manufacturing partners, everybody is on the same level. The communication is the same. The expectations and the consistency are the same, and the accountability is there. I mean, they know that we will not take delivery of the product if it does not meet our benchmarks. And so, you know, they want more orders, they want to make more money, so do we. And it's, you know, all of our stuff is our design. I mean, we are not an open mold company. We have designed, we have come up with the layup schedule. We've come up with the benchmarks for every single one of the products that you see that has Knight's name on it. So, you know, we didn't go over there. We didn't walk into a factory. We didn't say, hey, we got $120 to spend on a rim. What do you have that's 29 inches, you know, around? And then, you know, pick something, come up with a sticker, slap a sticker on it, and put it on the internet.
I mean, I think I want to say I saw a pink bike video where they did that, like where they're like, let's make a new bike brand, and they went over.
Actually, I love that video because it's the reason why you see so much saturation in our industry is, you can see, I feel like every time I look on Bike Room or Bike Radar or Cycling Tips, I'm hearing about another brand that's being started. And it's someone who, everything from Daniel at Tumbleweed, who worked at a bike shop, and he wasn't finding the bike packing bike that he wanted. So he made it. He basically came up with an idea. He went to Taiwan, he sourced a factory, he, gave him the design, and they made him 100 frames. And and I say that I love Daniel's bike. I think his bike is awesome, and it's because nobody does anything like what he does. But there's a lot of other companies that, they've figured, hey, why should Envy and Reynolds and Knight and Easton and some of the other composites brand, like, why should they get all the play? I can go over there, I can source an open mold rim, and I can put my name on it, and I can just, have them assembled in Taiwan or assembled in China, put in a container, ship to the United States, and I could distribute out of Los Angeles, let's say, and call it a US made wheel. Or I could just get the rims, build them in the United States, and call it a US made wheel. And it's not a US made wheel. It might be a US assembled wheel, but it's definitely not a US made wheel.
Yeah,
but I mean,
that's kind of shady.
and honestly, I mean, you guys, you viewers, ask where your carbon comes from. If you see a good deal on the internet and it's a name brand that you're not seeing pretty, well represented, like, a Specialized or an Intense or a Yeti, but it looks like a Yeti, looks very similar to a Yeti. Trust me, these bikes are not all created equal. And
the accountability. I fell victim to purposely buying some Chinese carbon in the past, and it was like, I was looking for like some like kind of like aero drop bars for my road bike, and it was like the name brand ones were like $200, and then this one that looked exactly the same was like 30, and it just really made me like, okay, well, what's the difference there? Like, I mean, it looks exactly like it. It's like in my head it's the same. Oh, it must be just the same manufacturer. And they're like, somebody told me, oh, those are the ones that just have a little variance in them or something like that.
And there's places you can go right now on the internet where, and I'm not going to say the company's name, where you can pick your drilling, you can pick the type of finish, whether you want UD matte, 3K, 7K. You can pick whether or not you want decals on it. You can pick what color decals you want on it, or you can put no decals at all. And they'll promise to deliver your rims in the United States directly from China in less than 2 weeks. And you can buy 2 rims to be able to build a wheel set for under $400. So, if you've got a nice set of Chris King or Project 321 or Hadley hubs, and you've already, and they're built onto an aluminum wheel set, and you want to try carbon, the temptation to go there is strong. I mean, you can build a carbon wheel set for under $1,000 basically. But the problem is that you might ride those things 2 weeks, or you might ride them for 2 years, but I can tell you that eventually they're going to fail. And then you're going to see the customer service and the development side is not going to be there. You're going to call them up and be like, hey, so these wheels that I got from you, they broke. And they're going to be like, yeah, wasn't it a great price that you paid for them? We can sell you 2 more for the same price, and you're going to say, well, wait a minute, and at the same time, like, you guys aren't just putting along on your bikes. You're riding them hard. You're going off drops. You're going fast. If this thing nukes underneath you and sends you flying 40, 50 feet down the trail, and you have an injury, now your liability and liability becomes a play. You're not going to have any liability from that company. Whereas, most of the US manufacturers that do carbon fiber, at least, we all have liability insurance. And so there's, we have some protection because our insurance companies have looked at our processes and said, yeah, we think that this is a safe way to do it. You're doing your due diligence. And so, we're going to back you in case something happens. And that's,
I mean, a failure like that could end in a lot of ways. And it could end in you just scrape your knee, or it could end in you're sitting in a wheelchair for the rest of your life.
Yeah, and I mean, we all know. I mean, we all know. We've all heard stories of. Unfortunately, we might not always directly know them, but we've heard stories of people who have had their lives changed by, accidents on a bike. Sometimes it's a car versus a bike, but in some cases it's just riding along, and then here's something that happened. But I mean, the good news about our industry right now is that for the most part, with the exception of a few outliers, our industry is very safe. The products that we're making are being pushed harder. They're being ridden harder. they're going faster, the suspension's better, the materials are better, the manufacturing is better than I would say it probably ever has been in our industry, whether you're riding aluminum or carbon fiber or steel. It's an exciting time to own a bike. It's an exciting time to be buying bikes and bike parts and really speccing your bikes out, because the hardest part is actually choosing what you want. Do I want a set of Envies or do I want a set of Knight wheels? Do I want the new Fox shock, or do I want to check out this new DVO, or do I want this new Cane Creek helm fork? Because there are so many good choices. And 10, 12 years ago in the industry, you had your clear front runner and then you had everything else. And now we've got a lot of products that, depending on how much money you want to spend, you can get a lot of bang for the buck without having to break the bank. And let's face it,
I think it's key, now that there is that, like that, now that the products are, let's just say, a lot of them are on the same playing field. I mean, then what you're really looking at is, what kind of customer service are you going to get? What kind of warranty are you going to get? How are they going to take care of you if, something's not right, or are they really going to be there for you? You know what I mean?
And I'm glad you bring that up, because I think that now, especially with obviously there's people within the industry that they're dedicated to going to bike shops. There's people that are starting businesses where they want to go direct to the consumer, but all of that comes down to, what all of that encompasses, is good customer service. If you can be available, if you can stand behind your product, if you can help your customer get the wheels that are going to best suit their purpose, or get any products, a bike, handlebar, hydration pack that's going to best suit their purpose. If you can give them that information, whether it's through your website or whether it's through, good old fashioned picking up the phone and talking to somebody, or going to your local bike shop and having an advocate in there be able to kind of, preach on your behalf. But that customer service side of things is what's going to keep our industry going. And it's going to make the difference between shops or businesses or manufacturers that are still here 5 or 6 years from now, or who are gone 5 or 6 years from now. And I think that, everybody that's in our industry has had that good experience, whether as a customer, whether it's buying a car, buying a stereo, or buying a bicycle. We've all had that kick-ass customer service situation where we set that, hey, this is our benchmark. Man, I had this one time where I got this coffee where this woman was like, here's the 10 different types of cream I can put in your coffee. Which one do you want? You're thinking, well, it was unnecessary, but I appreciated that you asked. And, that might make the decision between, riding another mile further down the road to go get coffee from her versus, doing the thing that's most convenient.
Yeah. I mean, it's like how do you pick your favorite bar to go have a beer at? It's
absolutely.
Like the one that has the bartender that you like talking to, right?
Yeah. In my opinion, I always go for the slutty Taya Leone. That's kind of my standard. Like, I like to start right there. And it's just like, well, if you start with slutty Taya Leone and go from there, it usually ends up being a pretty good bar.
All right. That sounds like a good benchmark for me. One of the people on the chat had asked a question, and I don't even know what half of it fucking means. So we're gonna have to explain it first to me and then answer their question. So he's asking, what's the typical spoke KPF on your enduro rim? What's KPF first?
So KGF is a build tension. It's a measurement of tension on the wheel. So it stands for kilograms of force. So we build our wheels to 130 kilograms of force. And the reason that we build them to that higher tension is, one, our manufacturing process allows us to do that because we have really, really high spoke pull through. Our spoke pull through is over 300 kilograms of force. Plus, with mountain bike wheels,
so that means it takes 300 kilograms of force to actually pull it through.
Yeah, and in most cases, and I'm going to tell you right now, the hub flange will fail before you'll ever get to 300 kilograms of force, or the spoke will fail before you get to 300 kilograms of force. So,
I was going to say, Jake from Project 321 will argue on the hub, right?
Yeah. I mean, it depends. Yeah, it's like anything else. I mean, not everything is made equal, but there's definitely some hubs out there that can handle that kind of.
I hate it when somebody says something like that, because all I want to do is fucking do it now.
yeah, right on. But yeah, we build to 130 kilograms of force. So a lot of rims, they go to like 120, 125 is kind of what's recommended. We do that extra 5 kilograms of force because the one thing that we realized with setting up tubeless tires, particularly on mountain bike wheels, I mean, some of these tubeless tires, if you go with like an Apex sidewall off of a Schwalbe, which is a really tough sidewall, you always inevitably end up with some settling after you mount that tubeless on the rim. some of the loss of tension can be as much as 10 to 12 kilograms of force, depending on your wheel manufacturer. So because we build to 130 and, we've got some things within our build spec, we're losing maybe 2 to 3 kilograms of force in ride settling if the wheel is built correctly, if it's even tension on the drive side, even tension on the non-drive side. It's usually, if this is 100% is 130 kilograms of force, our non-drive side tension with, say, a DT240 hub, let's just use that as a standard example, is usually about 75% of that tension, but it still needs to be even. So, if you do your adequate spoke prep, and we don't build with anything strange. So, I mean, you can build with DT Swiss, you can build with Supreme. We don't have anything that's proprietary about our rims. We actually made them to be friendly for wheel builders to be able to build up with whatever spec they choose and find them easy to be able to work with. The thing that we're pretty uncompromising on is if you build it to 110 kilograms of force, expect to start fatiguing and breaking spokes early, and expect them not to be as stiff or not perform as well as maybe you would expect. So, we're always happy to work with. Of course, we do our own building in house
Hang on, you lost me there just for a second. So, if they build it to 110, you were saying don't expect it to be.
Yeah. I mean, it's not going to. Yeah, if you build it to too low a tension, don't expect it to perform as well as we expect the wheel to perform, because part of that build process is you might not have a wheel that's as durable.
Because you said you guys do 130, right?
Yeah, we do 130. So 110 is going to be a lower spoke tension.
Yeah. Okay, I'm tracking now. So there was something interesting that you had brought up to me when I was chatting with you that really kind of shocked me. Was you were saying that with the carbon wheels that the less spokes is actually better. Can you explain that?
Yeah. So one thing that we've noticed is through our impact testing is, the standard with working with aluminum. Let's just start off with the aluminum just to kind of provide context to this is when you started off with aluminum wheels, if you wanted to build a stronger wheel for aluminum, you had to use either a higher gauge spoke, you generally had to add more spokes, and you generally needed to have, like, instead of doing 2-cross, you would do a 3-cross wheel. So for like a touring wheel, you saw with most people that were on touring bikes, they ran 36 hole 3-cross build on whatever hub that you choose. And you usually ran nothing lighter than, say, a butted spoke.
So just real quick for people that are not familiar with the build process, when he's saying cross, it's like how many times the spokes actually cross each other like an X in the build when you're looking at it.
Correct. Yep.
Just clarifying that for the people that are maybe new to mountain biking or new to biking in general and aren't you're saying
and that's definitely a good point. I always make the assumption that I'm talking to a somewhat educated crowd, and that's actually, I need to be better about just kind of trying to bring it down to, if you've never heard of this before, here's where I should start this conversation. So I apologize for that. But
no worries. That's what I'm here for.
So, I mean, what we found with a lot of our testing, and this is some testing that's been consistent, that's also been done with some other carbon brands that I'm familiar with, is because it's a insulated material, so carbon fiber is laid up and it's cured, and that's a material that actually deflects force. Aluminum is a material that tends to absorb. So if you want to, that's why, raise your hand if you've bent an aluminum rim. I mean, I've bent an aluminum rim. You hit a rock, you end up with a little bend, you grab your crescent wrench, you straighten it out, and generally you keep going. Well, with carbon fiber tends to deflect impact forces. That's why, some of you guys that maybe some of your viewers that have ridden carbon fiber products, you might have had a wheel or a product that tended to ride quite a bit harsh. Lots of, not a lot of vibration dampening. So you end up getting a lot of feedback in your hands. That's considered to be a very stiff ride. There's not a lot of compliance to it. So with carbon fiber, we have found through our testing that actually with a wheel, the more holes you drill in that wheel because of that manufacturing process, you're actually weakening that carbon fiber, because it's no different than having a void within that rim that doesn't, when you don't get that material consolidation. So you can build a wheel that's 36 holes, 3-cross, and it's going to be strong, but your weakest parts of that wheel are going to be where you drilled those holes. And so we found through impact testing, and we had third-party impact testing confirm this for us, is that we've actually found that a 28-hole rim that's built 2-cross actually has a shorter spoke, with the quality of the hubs that are available on the market right now, they generally have a little bit higher flange. They're generally somewhat symmetrical because of the disc brake on the non-drive side, and then just the shearing forces of what goes into, a high engagement hub on the drive side. We're actually finding that those rims tend to impact test higher for strength, and they also have better overall endurance durability, like on a bump drum. So versus a 32 hole also built with 2 cross, or a 32 hole built with 3 cross. So we've seen that the 28 hole is actually a little bit higher rated for impact before you start seeing a failure, or you start seeing fatigue or loss of tension on the rim. So
I just want to be clear for people out there that are, maybe you have the wheels that came on your bike and you're thinking about building a wheel. Do remember, if you're a bigger guy and you're doing aluminum, go for the bigger hole count. It's better
absolutely.
If you're doing carbon, then you want to go and actually go for the lower count, which is,
there's definitely a fine line. So when you start talking about road wheels, you start talking about descending forces. I mean, if you have a 20 hole radially laced front and you're 270 pounds, probably not going to be the right mix for you. Because generally that's going to be a lower profile rim. But also keep in mind with mountain is that there's another component to this, and that's going to be suspension. So that's something that we don't see on road bikes. We don't have suspension on road bikes. We also don't have the impact forces that you see on road bikes. But with most mountain bikes, if you're riding a rigid bike, then you're relying on your tires to be kind of your suspension. So you're running lower PSI. If you're running, an enduro wheel, you're talking about something that probably has 140 to 180 millimeters of travel in the front. You're looking at 5-6 inches of travel in the back. You're probably running anywhere from like a 235 to a 25, 26 tire. You take all of that and you combine it with the system on the bike, you're going to end up with something that's probably going to be pretty durable over the long haul. So why would you want to overbuild the wheel in order to get some durability out of it? And that was kind of the initial thought, that was the hypothesis that we were able to confirm in testing. But you still need to have the minimum number of spokes to be able to build a strong wheel, because there is a tipping point. It's like a bell-shaped curve. And so that 28 holes in that enduro wheel that's 27.5, as you start to go down to lower spoke counts of 24 hole, you start seeing kind of similar results that you see with something that has maybe 32 that's also 2 cross, or even less. So there's definitely kind of a bell-shaped curve, and it's related to the material. And I want to clarify, this is specifically with the testing that we've done with our wheels. So factored into that is going to be our manufacturing process, the way that we manufacture our rims, the type of material that we use to be able to build our rims. That also factors into that durability that we're talking about. So, what
you're saying is it could be different with an NV wheel. It could be different with, a Derby wheel or something like that.
Absolutely. And if you look at most of the higher end carbon wheel manufacturers that are out there, at least those that are accessibly based in the United States, just about all of them do most of their mountain bike wheels to really similar drillings to what we do. They may offer a higher drill count, but most all of them do 28. I know the Big S out of Morgan Hill, they do a lot of their stuff in actually 20 and 24 for their mountain bike stuff. So especially like on some of their racing mountain bikes, which, I don't know who races mountain bikes anymore, but the people that still do, that want that really lightweight cross country wheel, they're risking 20 and 24 on like their Control SL, which is a 370 gram lightweight cross country rim that you see raced on the World Cup circuit. So not my cup of tea as far as that wheel is concerned, but I like having 28 spokes. I've had really good durability with it. I think when you start seeing dyno hub companies and roll off doing 28 hole hubs, I think you're going to see more people realizing that when you use something like a composite material, that you don't necessarily need to overbuild the wheel in order to still have a strong wheel. Tension still needs to be even, still need to do all the other stuff you would with any other wheel, but you don't need to overbuild it as far as the material is concerned.
Anybody can go on YouTube and take a look. There's videos out there. Like if you have a aluminum wheel, I talked to you about this before, and it has no spokes on it, and you just lean your weight on it, it will fold right in half. And you put a carbon hoop with no spokes on it, you can put one in each hand, and you can lift your feet off the ground, and they're not gonna buckle. So definitely a huge.
What was one of the things that I did with a rim that we pulled off the rack with you standing in front of me when you were visiting? Do you remember what I did with that rim? Do you remember me smashing it on the ground?
Yeah, you did. You bounced it right off the ground. I was like, what the fuck is wrong with this guy?
Yeah, I mean,
then you were like, here, you can have this one. No, I'm just kidding.
yeah, I was like, so this is your wheel. Yeah.
No, and you know what I do want to ask you about, and it's probably, some people don't know. When people are looking at carbon wheels, there's these measurements that people are always talking about. Is that inner or outer? And what do those numbers mean in that circumstance?
Okay, so with any bicycle wheel, and it seems like diameter has become a bigger part of the conversation in the last.
Oh, he locked up. Uh-oh. Well, welcome to the internet. This is the Wild Wild West. Is it just me? Let's see if I'm down. Whoop. Do this. Oh, yeah. Nope. Just him, huh? He gone. Let's see if he maybe he does. Yeah, he dropped off my thing too. See if he gets back in here in a second. In the meantime, I'll just be the entertainment for you guys. Looks like he's back.
There we are.
Yeah.
Dude, I don't know what happened.
I don't know either, but I was like, well, guess I'm just drinking by myself now.
Yeah. Sorry about that. Yeah, I am in Baker City, so
Yeah, no worries. So you were saying
maybe I need to send somebody downstairs to put some more quarters in the machine.
Right? So we were talking about in outer width. So.
Yeah, so inner width is generally related to the inner part of the rim, and then the outer width is going to be the outer part of the rim. And so that's going to be, so like, just as an example, our enduro rims are 30 millimeters internal width. Our external is going to be 36 and a half for this. So that means that you have about 3 millimeters of sidewall thickness. And so you look at the inner width because you want to look at the size of your tire as far as how the overall profile is going to be. So if you're running like a 2.4 tire and you've got a 31 inner width, you can look at how the inner part of the bead is going to sit on the tire. So that's going to be like this. The outer part of the bead is actually going to give you that shoulder just above the bead where it's going to rest. And then you look at the overall shape as far as like what kind of traction you want to have. So as an example, like a Hansdamp from Schwalbe, that's a fairly common tire. It's been around for a number of years. I could tell you that if you take a Hansdamp and you put it on a Stans Flow rim, it's going to look very different than if you put it on one of Ray's Derby DH rims that's, a 36 millimeter internal width. You end up getting a pretty significant change in the amount of available traction that you have from that tire. So the internal width question is based off the type of riding that you're going to do. So if you're a cross-country racer who's looking to maximize speed and has low tread, you might run a really narrow, and by really narrow I mean like a 22 and a half internal width, maybe a 27 external width with like a 29 by 2.1 tire. Or you might take that same rim, you might put it on a gravel bike and you might run 700 by 35 or 700 by 40 on your gravel bike. But at the same time, like, I'm riding a plus size bike right now with a 3.0 tire on it, and so Knight makes a rim called the 27.5 plus, and it's 45 millimeters internal width with 51 millimeters external width. I choose that rim for that 3.0 tire because like I'm running, what am I running right now? I've got WTB Rangers on my bike right now. And those Rangers, in order for me to get the maximum amount of traction, I need to have at least 45 millimeters of internal width to space that bead out far enough to be able to square that traction off. So really choosing the bike that you're riding, choosing the type of tire and the size of tire for your riding that you want to use, and then picking the rim and also just making sure that you got room for it to fit in your frame, because that's a mistake I see a lot of people making right now is they've got an older bike like a Turner 5 Spot and they try to slap a 2.5 tire in that thing and it ain't happening, I can tell you. So, Until David starts making bikes that have boost spacing in the rear, you're going to be pretty limited on what kind of tire you can put on a bike like that. Doesn't make it any less capable, but you're definitely going to be limited on your tire size. So internal wheel is.
It seems like some of the bike companies are really starting to build that way. I mean, like Santa Cruz this year, I honestly had absolutely no reason that I wanted to get rid of my Bronson, and then they released their new frame this year, and it's like you can go all the way up to 2.8 on it, and I think, you know, what they're doing, this is my assumption, is you're making a bike that can kill a quiver, you know, so you can put a 2.8 wheel on there when you want to, and then you'll be able to put, you know, a 2.3 on there when you want to for that, you know. I think what then in the future is the suspension is going to change in a way where on the fly you can actually make your bike seem like it's a 3-inch bike, and then on the fly, hey, it's time for us to get down, and now it's a 6-inch bike, you know.
It's coming. There's going to be some metric suspension stuff that's coming down the pike that you're going to have 3 different presets. It's going to be like having 3 different drivers for a car, where you get in, you hit a button on the dash, and it moves your seat and steering wheel where you want it to be, where you're going to be able to preset your suspension, at least on the shocks, to where if you're in more of a pedaling platform, you can flip it to that, and it's going to be, you know, you're going to reduce the bob. If you're going to be just trail riding, you might flip it to another setting that's going to be more conducive for trail. If you're at a bike park and, you know, you changed from your 27 by 2.8 tire and now you put on a 29 by 2.4, you might flip it to that 3rd setting because you're about to get gnarly on something that's a little more flowy and park oriented. So I agree with you. I think that a lot of bike companies are now starting to offer stuff where you can run 2 different wheel sizes without changing your bottom bracket height or your overall length of your bike. A lot of the shocks that are and suspension that's coming out is kind of being built with that in mind. I think that having 1x component groups and going to that boost spacing is making it a lot easier to be able to accommodate multiple sizes of tires. And frankly, not everybody has a garage to have 6 or 7 bikes in it anymore. So, I mean, if you're one of those lucky guys, then that's great. But if you're not one of those lucky guys, you're going to look for a bike that can do a lot of different things, because there's a lot of different variables in the type of riding people can do. And they don't want to be left out in the cold because they don't have the right bike. So they're going to look for a bike that can do a lot of things. And, you know, something like the Chameleon that you and I were talking about. I mean, I think that Santa Cruz's hardtail, being able to run a 29-inch wheel or being able to run a 27.5 plus with, you know, pretty big fork on the front, like that's an incredibly capable bike for someone who can do just about everything and wants to own a hardtail, doesn't want to mess with having to have shocks rebuilt. So I think we're going to see more. My opinion is we'll continue to see bikes like that coming onto the market and kind of being the standard by which most enthusiasts are buying.
You know, they have to do that. You have to make these newer bikes like a quiver killer, because the cost of the bikes are going up so much. I mean, back in the early 2000s, you could have 5 bikes, but they were only $2,000 a piece.
That's right.
Know? So it's like now it's like you buy, you know, let's just say a entry level mountain bike that's like, you know, kind of really getting you into the fairly decent quality is at least $3,000. You know, and at $5,000 to $6,000, you're getting like, yeah, this is a pretty like almost, you know, top line bike. And then that you know, diminishing return after that $6,000 to get to that like 9 or 10, it's like, okay, you know, maybe you just ride the $6,000 bike and you're gonna break some derailleurs and stuff like that, and you can upgrade those as you go. But to be, you know, like, so let's just say the middle of the road there is $5,000. I mean, get to have 3 bikes, that's $15,000. I mean, that's, you know.
Yeah, I mean, I think that the bang for the buck between $5,000 and $7,000 is pretty incredible. You can buy a lot of bike, and even those $3,000 bikes, like those $3,000 bikes now, like with some of the trickle down on some of the components from Shimano and SRAM. I mean, those $3,000 bikes now are better than the $4,000 bikes were 5 years ago. And when those were like at the high end, like, I mean, I look at some of the stuff that SRAM is doing right now, or even Shimano, like SLX brakes. I mean, SLX brakes you see on bikes that are, you would classify as inexpensive, but I mean, grab an SLX brake and then, you know, grab an XTR brake and modulate them and ride them for a while. it's a very, very slight difference in weight. And I'll tell you, performance wise, there's not a lot of variance between those. So, if you end up with a $5,500 bike that has SLX on it, like, don't be sad about your brakes. You ended up with a pretty good brake set on your bike.
Yeah, and I'll just say that to be clear, especially if you're a lighter guy. I mean, it's definitely a different game if you're a big dude.
Yeah, I'm 150 pounds, so I can pretty much play on just about any brake that I want, and I don't have that consideration.
Engineered for you.
Yeah, no, they definitely they definitely aren't. But I mean, I've got a buddy that I ride with. I mean, that you got to meet on your trip to Bend. I mean, Jake rides, he carries a little vegetarian weight with him, and he gets pretty rowdy on the bike, and obviously his component selection is going to be very different than mine. But he does not ride the most expensive stuff that's out there. He rides stuff that can handle the amount of stress that he puts on his equipment, and he chooses his build spec based off of that. So it's not just about, okay, I'll take the most expensive thing that's on the market because I can get it because I'm in the industry. It's more like actually catering his build specifically for the type of riding that he's going to do, and also being honest about how much load he's putting on the bike himself versus the load he's putting into the bike as far as the type of riding that he's doing. So
yeah, totally. I think that's something that you have to be cognizant about, and in some cases, the more expensive one isn't necessarily even better. I remember when I was like learning about like the different like ranges of like Shimano, for example, and somebody gave a perfect example that I still use today. And it's like, what's the difference between XT and XTR? Like the XT one's going to last. The XTR one is more expensive just because it's lighter.
Yeah.
So go with the XT. If you're really worried about the difference in weight between the two, fucking shave your beard.
Yeah. Most people won't. It's not a measurable gain for. That's a measurable gain for 1% of the population that's out there. For the other 99%, you're just spending money to spend money. You're not actually getting a performance benefit from it. So yeah, buy it, like save the money, get something that's going to last you a little bit longer. And chances are you're going to be just as happy with it as you would be if you chosen to spend more money.
So what do you think about some of these different like drivetrain systems and maybe how that would affect the wheel itself? If let's just say, for the sake of conversation, if bikes went completely to gearboxes and you didn't have to worry about that cassette and stuff like that on the side of your wheel, would that change the way you guys engineer your wheels?
Yeah, I mean, the things that are gonna affect the engineering is, I mean, when we look at radial loads, or we look at lateral loads, or we look at how we tune the wheel for how the wheel is going to be ridden, really how the bike and how we look at the wheels as as being part of a system. So it wouldn't just be the gearbox system. The things that I think we're going to warrant more consideration are, over in Europe, the e-mountain bike it's nuts. I mean, Eurobike this year, I'd say 70% of the biggest booths that we saw there were having rowdy, full suspension, long travel e-mountain bikes. And they are definitely a way of life over in Europe, and they're gaining accessibility in the United States because we've got the population that we have. And, I think in the US, they're going to be the last place to take off, but the industry isn't limited to just the United States. So, the considerations in doing a carbon fiber e-bike wheel are going to be very different than what we're going to do, just because of the amount of forces on the hubs. Those e-bikes, they accelerate so quickly. So actually most of the stress is going to be on the spokes and actually on the driver and on that hub. And obviously that's going to resonate outwards towards the wheels. For us, because of the way that we manufacture our wheels, we're going to maybe have to change our layup schedule a little bit. We might tune them a little bit differently based off of that quick acceleration and deceleration. But I think that the stress for people is actually going to be on the hub manufacturers and on the spoke manufacturers, much more so than the tire and the rim manufacturers for systems like that. But yeah, I mean, we've got customers that ride pinion system bikes, like the Zeroed Taniwa is a good example. Those guys, Neil at Cycle Monkey, he distributes those bikes in the United States, and we've got some customers that own those bikes that ride our 27.5 Enduro rims on that. And I mean, the performance is, I don't really, personally, I don't like the play in the pinion gearbox, but, we're not seeing any additional load on the rims because of a gearbox system. And because we're an innovative company, if that crazy ceramic speed, chainless derailleur-less drivetrain, if 10 years from now that's the norm on all bikes that are around, we'll adjust, we'll amend, we'll see kind of what that does to the wheel, what that does to the hub and the drive system, and us, and I'm sure every other wheel manufacturer in the industry will make changes to accommodate and hopefully accelerate the development of products like that. I mean, this is a very malleable industry. We respond to trends and we respond to change pretty quickly. And most bike manufacturers, most component manufacturers, they don't wait 4 or 5 years to finally wait and see if something's gonna stick. We can bring things to market pretty quickly, so we're able to respond to trends faster. We're able to test them and bring them to market faster. And then if something doesn't stick, we can let it go away and move towards another trend, or even try to set a trend or set a standard if we see a hole available that we can try to fill.
Interesting.
Yeah, it's not going to change us unless we need it to change.
Yeah. Somebody here is asking, what's the difference in fibers and resins that can be used in a layup?
Man, that's a whole nother conversation. So there's different, just like everything else, just like if you go to the store and you buy sheets for your bed, you'll look and you'll say, this has 100 count cotton, this has 300 thread count, this has 800 thread count. Well, carbon fiber material is the same way. There's different levels of composite material based off of how that material is going to be used. So, if you've ever flown on a Boeing 777, 777 has 2 engines underneath the wings, and under each wing is this single engine. And the air that comes into that engine has fans that move that air through the blades. Well, those blades are made out of carbon fiber. It's Toray T700. Same thing with the leading edges on those wings. That's Toray T700. That Toray T700 is probably not going to be the same material that's used to make something else that's like an intake on a Subaru. That's probably not going to use that same material for something as simple as an intake on a Subaru. You're probably going to use something like 3K. So usually the type of material that you use is going to be based off of how the product is going to be used by the end user. What's the level of stress? What's the load? What's the demand that's going to be placed on the material? So, that's the difference between, maybe the 100 count sheets and the 600 count sheets. Well, it's the same thing with the carbon fiber. And then, the resins, they're based off of, how much weight you want to put into something, the type of performance, how you want to tune the wheel as far as the layup. So both the material and the resins can factor into, a wheel that's going to be more stiff or something that's going to have a little bit more compliance. So everything works as a system, whether it's the frame, whether it's a handlebar, whether it's a bicycle wheel. The material that you use is going to be based off of what you want from a performance standpoint from that wheel or from that product. It also makes a difference in what that product is going to cost. So yes, all of you can get on Google right now. You can Google carbon bicycle wheel, and you're going to see wheels that are $300, $400. I mean, even a brand name like Trek has a wheel set that's $660, and it's carbon fiber. Well, they also have wheels that are $3,000. So ask yourself, what's the difference? If those $600 wheels are good enough, why are they still making those $3,000 wheels? It's because the $3,000 wheels are what you're going to see Trek Roll racing on, what you're going to see Segafredo racing over in Europe. It's a higher level wheel because it has a higher level of material and a higher level of durability. So you get what you pay for with components and especially with wheels. So, we're not the most expensive wheel in the world. We're actually not anywhere close to it. We're kind of in that mid-level. We do spend a fair amount of money on our development and on our tooling and on our processes, but we also know that there's a lot of margin to be made on there, and we're not just making margin because we have a ton of overhead. We have lower overhead, and so we try to make our products accessible to customers so that they can get out and they can enjoy them and they can ride them and they don't feel like they need to take out a second mortgage on their house. I would rather have you take that $1,000 that you save on buying wheels from us and come up to Bend and ride some of our rad ass trails that we've got up there and drink some of our beer and come and visit our town versus spending an extra $1,000 just to have something that has a different name on the side of it. So that's kind of our philosophy on that is, you know, you don't need to spend $4,000 on wheels unless you really, really want to. But chances are the person who spends $4,000 on wheels, they probably aren't driving a Dodge. You know what I mean? They're probably driving something else. So
yeah. Well, you guys definitely have some good beer. I did maybe partake in a little bit of that too much. And then
that's good to hear.
Did get a hold of some of your riding up there as well. Somehow or another, I got talked into a shuttle that was like Mountainese from the very beginning. So that was pretty interesting.
Right on.
Somehow
sounds like Jake might have taken you on farewell. So
oh yeah, it was like, oh yeah, it's only gonna be like 14 miles and 600 feet of climbing, and instead it was like 20 miles and fucking 1,600 feet of climbing or some bullshit like that. So every hill we came to, he was like, oh, I forgot. There is this one too. But it was, you know what? Any day on the dirt is a good day, so I'll take that, 8 days a week over freaking, on to my regular day job. So,
right on, man. Absolutely.
So there's a shit ton of stuff out there being made out of carbon nowadays. And from your perspective, somebody that works in that industry, do you think there's some stuff that just shouldn't be made out of carbon?
Yes.
Do you think that
I'll just leave it at that. Yes. I think that there's I just saw a carbon fiber mountain bike pedal, and I don't think that's necessary. I think that it's going to be expensive, and I don't necessarily think it's going to be any better than some of the aluminum stuff with the steel axles that's out there as far as durability is concerned.
Yeah.
I think personally, carbon fiber hub shells on bicycle hubs are kind of law of diminishing returns. I know there's some companies that do them, and they do them well. I don't think it's necessary as far as strength or weight savings. You're spending a lot of money on something that you're not necessarily improving your performance with. So, I mean, specifically within the bike industry, there's a few other things, but I'm not going to get into it because I have respect for anybody who tries to innovate and tries to bring new products into the industry and tries to move our industry forward. So, whether I choose to partake and consume in it is a personal choice, but I definitely appreciate people that try to do stuff a little bit outside of the box. Now it's up to them whether or not they make money on it. That's their business. But, I definitely think there are things that we don't necessarily need to have made out of carbon fiber, but same thing could have been said about titanium, but I love titanium.
So somebody on here asked, can you ask how much weight is saved from carbon and high-end aluminum rims? And I think that question, and I'm not sure because he follows it up with something else, but for me, I don't necessarily think it's always about weight with carbon to aluminum, and I think some people do look at it that way. I think for me, it really has to do with that wheel not flexing and how it changes your ride characteristics more than the weight. Because I think you can get wheels that weigh the same now, right?
Yeah, absolutely, you can.
So then he says,
you can also get.
Go ahead.
Yeah, you can also get, but I mean, you're also going to end up with an aluminum wheel that, is going to absorb a lot more versus deflect. So you're not going to end up getting the same amount of responsiveness. You might have an aluminum rim that's 440 grams. You might have a carbon rim that's 440 grams. And these two wheels are going to ride very, very different. So if you just look at the numbers and you don't look at the overall ride performance, you're gonna, if you were to be neutral and just appraise both of them, that carbon wheel is going to ride a lot more responsive. It's going to be stiffer. You're going to be able to get more out of the tire. You're not going to be limited by the material within the wheel. Whereas with the aluminum wheel, in some cases, you could hit a rock wrong, and now suddenly your rim is not going to hold the beat of your tire anymore. Or you may end up with some tire flop because the material of the aluminum will deform when you really push the tire through the turn because you have really firm sidewalls on your tire because you're running like a tough downhill tire. So in most cases, you're going to see a pretty different ride characteristic between the two materials. I mean, if aluminum was the greatest material in the world and it was equal to carbon fiber, most of the industry would still be making high-end stuff out of aluminum. The fact remains, it isn't. All of the high-end stuff that we're seeing in the industry is all being made out of composite because composite has proven to be a more durable, more performance-oriented material than aluminum. And that's industry-wide. That's not manufacturing. That's industry-wide.
I hate when I see people like talk about the carbon fiber with frames or wheels, and they're like, "Oh, well, it breaks," and go look at the failures. And I'm like, "Yeah, dude," but also go online and look at freaking just bike frame failure videos on YouTube, and you can see half the fucking videos are aluminum and half of them are carbon. It's like if that shit's gonna happen. I mean,
failures occur whenever you ride and you push something. Failure is going to occur, no matter whether it's a steel material, whether it's a composite material, whether it's whether it's an aluminum material, and it could be because of manufacturing defect. It could be side of its intended purpose. Like, remember that video where the guy, I think that was on Pink Bike or somebody, where Bernard Kerr or some badass downhill free ride guy went to Walmart or Kmart and bought some clapped out something or another, and he took it down a line at Whistler. And I mean, that thing was gone by the time he got to the bottom. And it's like, but he pointed out, and at the very end, he pointed out that his race frame was made out of the exact same material as that bike he had bought for $200 at Walmart or Kmart or whatever. He said, this is the same material. And he said, not all aluminum is created equal, or not all steel is created equal. And, even with a rider with his skill, he managed to mangle this. Yeah, it's a great video.
If I remember correctly, that there was a YouTuber that did it. His name's Paul the Punter. And I know there was
I saw that one. That one was horrible. That one was horrible.
A guy too that did it wasn't a carbon bike. Phil Metz did one too, where he took like a Walmart bike down a downhill run, and that was fucking hilarious.
Yeah, I mean, there's an Italian guy who every year he takes the bike that wins the Tour de France. So like the last couple of years, it's been a Pinarello, and he's taken it to La Bresse and ridden it down they have this, like, it starts off, it's like a kamikaze style downhill, and he does it on this road bike. It's this hysterical video, but he destroys this thing. I mean, half the time the handlebars break from crashing because he's flexing this bike so much the handlebars actually break off in his hands, and he's just like, well, still he's like the Tour de France winning bike has still not been able to make it down La Bresse. So yeah, I mean, that's what I love about the internet.
You would think those things would be like, I mean, I don't understand how he even gets it. Like, you would think those things would be selling for like $100,000 to some fan or something like that. He's just out there.
Yeah, no, I don't think it's the actual Tour de France winning bike, but I think it's basically an exact replica of the one that wins. But yeah, but the funny thing is like, that's what I love about the internet, because guys wake up in the morning, they're like, you know what I'm going to do today? I'm going to fucking grab a Pinarello and I'm going to try to take it on this kamikaze downhill just to see what's going to happen to it. This is the most capable road bike in the world, but yet here we're going to expose it for everything that it's not. So that's what I love about the internet.
Yeah, and then you also get to hear a fat guy make a complete ass out of himself in about 10 seconds ago. So that was fun. So the other thing that the guy was asking when he was talking about the carbon and aluminum, he says, is it the stiffness of the wheels that really makes the power transfer to the ground?
Sometimes it could be tire choice. Sometimes it could be suspension setup on the bike. Responsiveness and stiffness are definitely two different things, because you have radial stiffness and you have lateral stiffness. It could be the difference between having a quick release and having a through axle system. So, it also depends on the rider weight, how the rider is going to use it. Generally, because carbon fiber is a material that is consolidated, versus extruded, you tend to naturally have more stiffness out of a carbon fiber material than you will out of aluminum. So it allows you to run a much wider range of tires and actually get the intended performance out of the tires, whether you want more compliance or whether you want stiffer sidewalls. Aluminum, you generally don't get that same kind of variance. So it's not as simple as just, well, this material is stiffer than that one. But it does carbon fiber allows you more consistency in being able to tune what tires and what suspension how you set your bike up, as far as the type of predictability in your performance that you're going to have. Because you could take one aluminum rim, you could put 5 or 6 different tires on it, put it on the same bike, and you're going to get 5 or 6 different responses out of that bike. And with carbon fiber, you can put those tires on there, and it's going to be based off of now you're tuning your PSI, now you're checking the PSI in your shock. Now you're looking at kind of how you tend to ride, where's the tire going to break loose versus where it's going to hook up. And you're able to just kind of establish more consistency with the carbon fiber material in the wheel versus what you're going to get out of something that's in aluminum.
So this the other thing, I thought of, since you're in the industry of the wheel industry, can you talk to people about, what the benefits actually were of going to Boost and how that has changed maybe how wheels are? Because I think for a lot of guys, they may have a bit of an older bike that doesn't have a Boost wheel, and some of the like the six-pack talk on the tailgate is like, it's just the fucking bike companies trying to make some new standard this year, so we got to go buy.
Oh yeah, no. And listen, to be fair, I was one of those guys that when I first heard about it, I was just like, well, this makes no sense. But now, after some retrospective, I can't speak to what the rest of the industry is thinking. I can tell you from the wheel side how this has directly affected us. So, if you remember when Boost first launched on bikes, we had barely started getting into we were doing a lot of bikes were 2x11. So from the gearing standpoint, and usually the tallest cassette that you had maybe was a 40, probably was a 36. Going to a 1x drivetrain really started when people started looking at 1x drivetrains. That's where they started looking at, okay, how can we get more gearing that's going to have a good chain line into that rear end of that bike? And they also started looking at axle tracking on bikes as far as the rear ends were concerned. And so they realized that by spacing out that rear end, you could get more tire into the frame. You could actually get more travel depending on your linkage on a mountain bike. You get more travel out of the frame, but you actually end up adding gears to that rear end by getting a more consistent chain line. So by running that 1x ring in the front, 32, 34, and then having a range with SRAM Eagle, you can get a 1051, which is just a crazy range of gearing. I think that Boost allowed bikes, particularly on the mountain bike side, to become more of a quiver killer. It became something that you didn't need to have a specific downhill bike or a specific trail bike or a specific cross-country bike. You were able to have a bike that you could tune with this gearing range to where you could ride in. You could use that same component and you could put it on a fat bike and you could go ride in snow at 3.5 PSI, or you could put it on a Santa Cruz Bronson and you could pedal up and at the same time get rowdy on the way down. I think not everybody shuttles. A lot of people like to ride. So also knew that tires, I feel like a lot of tire manufacturers were being held back from the tread perspective by the confines of the limitations of the sizing in the frame. And so they knew from doing research on how tire tread hooks up and also the ranges in the PSI that, if the biggest tire you can squeeze in the back of a bike is 2.35 or 2.4, you're going to be limited in the amount of available tread that you have there. So that makes you change your siping. That makes you look at the amount of space that you have between each tread. So with having Boost and having a little bit wider space, now you can have a little bit wider rim. Now you can have a little bit wider tire. So, who here has ridden a dirt motorcycle bike that has a 2.1 tire on it, like a dirt bike, like a YZ80? No, you look at motorcycle tires that have a lot of power and a lot of suspension, a lot of torque, and they got big tires on them. So at least from the mountain biking side of things, I think Boost has been a good addition because it's allowed us to simplify our drivetrains, but it's also really allowed us to expand the amount of available tread and tire that's available. And it's also allowed us to make wheels a little bit wider, so you're able to maximize that tread much more so than we were with rims that were 19.5 millimeter internal widths. So that's where I've seen it directly affecting it, and I think it's actually a good thing. Is it just allows us more available traction. Our tires get to become a tool for mountain bikers again, and you're not limited by them anymore. So that's where I think Boost has made a positive impact. Look, I still have a bike that I love to ride that's 142 spaced in the back, and but I understand its limitations. But I also have a bike that's got a Boost rear end, and I tend to reach for that one more than I do anything else because I like riding that I like riding that bigger tire in the back. So
yeah. I can always say, the best bike to ride is the one you're on, right?
Yeah.
And I can also say that, in the 90s when I was riding a fully rigid mountain bike, I had just as much fun as I have today on my freaking badass Bronson over there. Yeah. But there is definitely there can be a lot of changes in how much fun you have or how comfortable that ride is or how reactive that bike is, and those are the things where you're like, it's just it really like blows my mind how much this industry has changed in the amount of time that it has. And it seems like lately, we're on that same curve that like computer systems are, you know, it's just like things are changing so fast.
Yeah, I mean, I went to an event last year where, you know, the bikes had to be at least 25 years old. It was a mountain biking event, and the bikes had to be at least 25 years old in order for you to compete in this event. And the overall sentiment at the end of the event was like, thank God we don't have to ride these things anymore. And I mean, and there were great bikes. There were, you know, some sweet looking Richies there. There were some, you know, OG WTBs. There were some great Bridgestones, but most of my circle, at least, we all came away with was like, wow, that was fun. It was rad. I forgot how bad Canties will not stop. You know, I forgot, you know, just the overall long top tubes and, you know, lawn stems and the positions and the bar ends and stuff like that. But we all kind of came away from it going like, man, it's a great thing we got out of the 90s with our lives not having broken necks or back pain. And thank God we don't have to ride bikes like this anymore. So it's like anything else. I mean, nobody drag races a Model T because those cars were super limited and super capable, but we all have an appreciation from where the automobile industry came from. We're just glad we're not there anymore. So I feel the same way about the bike industry.
Yeah, it's funny you said that about the brakes. I had a buddy of mine that had an older bike, and he had never been on hydraulic brakes before. And we were sitting on top of some hill one day, and I was like, yeah, let's just switch bikes, dude. And he's like, oh, okay, cool. You sure? I'm like, yeah, dude, go ahead, jump my bike, man. So we're fucking hauling ass down this trail, dude. And I'm just on his fucking ass, right? You know, just like, yeah, just right on the back of his tire, riding how I always ride, right? And then all of a sudden we get to this spot where you need to slow down, and he's like, whoop, right around the corner, and I yanked the brakes, and that thing didn't fucking do anything, dude. I about shit my fucking pants, man. I'm like heading off into the trees. I'm like, holy fuck, man! I completely forgot how bad those brakes were, man. It was like, yeah, it is definitely like, and it leads to why I always tell people now, like, if you want to know if you're like what a good brake, or like if you want to know if your brakes are bad, buy better brakes, and then you'll find out. Because once you have better brakes, you're like, wow, I don't even know how the hell I was doing that before. You know?
Let's take our respective respective experiences on cantilever brakes, and let's raise a high five to guys like John Tomac, who used to go hella fast on bikes of that vintage with brakes that sucked that bad. But if you look at the way Johnny Tomes used to ride his bike, that dude never had his hands on the brakes. He was like 1 foot out, aero helmet, disc wheels, ripping down some mountain, and he was just like, fuck it, I'll hit the hay bales when I get to the finish line. Like that guy, you know, I mean, but that's the reason why he won everything. He won downhill, he won cross country. Is, you know, back then when you couldn't stop, it was just a matter of how much were you willing to risk it. And you know, now there's, I think, quite a bit more skill in what you do, and obviously the bikes we're riding are a lot better. So
I think it's like, was he in that group of guys from Marin that were all the clunker riders?
Oh no, those guys were all on coaster brakes, man, or on roller camp. That's like Charlie Kelly and Gary Fisher and those guys. Those guys were even more nuts.
I want to say that Gary Fisher's time on freaking the repack trail still hasn't been, still hasn't been beaten. Like,
yeah, no, he was those guys, you know, and I'm sure if, like, you know, you took some of you took 5 good level riders in the United States and we're like, guys, we want you to spend 4 or 5 months focusing on breaking this repack record, they'd probably be able to do it fairly easily. I mean, those guys like Charlie Kelly and Gary Fisher and that crew from Marin back in the day, you're talking about times that were set over 6 and 7 years of and weekly rides, like just bombing down this thing every week for 6 and 7 years at a time. And eventually you get the courage and you get the speed and you get the, oh shit, this can't stop. I mean, it's like when you see downhill guys that lose their chain at the start. I mean, I remember, what was it? Nico Mullally a couple of years at Worlds. I mean, the guy hadn't been top 15 in any World Cup race all year long. He blows his chain at the start. He ends up getting 4th in the world because he stopped thinking. He was just like, well, shit, I got to keep speed going because I can't pedal. So I have to keep speed. I can't touch the brakes when I'm going through this rock garden. And he ends up getting his best World Cup result of the year. So, I mean, I think that, you know, with guys like that, you know, you look at Gary Fisher now and you're like, there's no way that guy was fast. He's wearing a purple suit. But I mean, like, you know, you look at guys like that now and you realize, like, back in the day, they had to learn like where those limitations, and once they, you know, they busted through those limitations, they were able to realize like, hey man, with wide handlebars and a coaster brake bike and a double top tube. I went in a pair of Levi's jeans. I went pretty damn fast down this hill. So I have a lot of respect for what those guys were able to accomplish back in the day. But at the same time, like, I'm glad that's not my mountain bike. You know what I mean?
Yeah, those guys definitely were amazing. So
riding in jeans is dumb. Who does that? You know?
So let's go ahead and start wrapping this thing up. I wanted to ask, is there anything in particular that you guys are looking forward to in the future with Knight Composites?
Yeah, so being a composites company, and we really wanted to focus on for the first years of our development, we wanted to focus on where most of our cumulative experience was going to best be was kind of benefit the industry, and wheels was that category. We obviously want to look at continuing to make great wheels, continuing to respond to the industry, innovate the industry with the way that we do things, but we're also looking at expanding out of rims and getting into some other parts in the bike industry where we think composites can be well represented, and with our lead engineer Kevin Kwan and his team, aerodynamics specifically being kind of at the forefront of that. Like Kevin's philosophy and kind of approach to how he looks at aerodynamics and specifically ergonomics with things like handlebars. I think you're going to see some things out of Knight Composites that might break some industry norms as far as how road bike handlebars and maybe mountain bike handlebars and maybe a few other components in the next couple years. So we're excited kind of for those next steps and seeing kind of where that goes. But yeah, we want to continue to have wheels be part of our foundation, but we always look forward to the next steps. But we're not going to sit. We're not going to sit. We're going to continue to try to push forward and continue to get better.
Hey man, I really truly appreciate you taking the time to sit down and chat with us tonight.
Thanks for having me.
Super fun talking to you, man. You're crazy knowledgeable, man. I hope that I can retain like half of what you said tonight, but really, really, really appreciate you coming here, man. And for those of you guys that are out there in the ether, this show's every Sunday at 5 p.m. PST. I really appreciate everybody hanging out here today, watching it live, and those of you guys later on watching that as you're sitting in traffic or listening to it in traffic. Thanks a lot to everybody, and we'll see you guys next week. Remember, it only takes a bike to be a biker. Get out and be one, bitches.